This is questions 19, 23 and 29 in exercise 1.7 in Project Maths 3A. We have to solve for x in each of the following quadratic equations. So we'll start over here with 19. With this particular quadratic equation, because there is no constant at the end of our expression on the left of the equal sign, and what I mean by that is no number without an x attached, we're just going to factorize these two out to start with. So the highest common factor between x squared and minus 4x is x. And then inside our brackets we're going to have x minus 4. Because if we multiplied out these brackets, we'd get our original expression on the top. And this is still equal to 0. And what that means here is we have this x here, we multiply by this entire bracket here, and our result is 0. Which means that either one or both of these things is equal to 0. And for the sake of this, we're going to say both of them are. So we're going to say x equals 0, and we're going to say x minus 4 is equal to 0, which means x is equal to 0 and x is equal to 4. So those are our solutions for question 19. If we look at question 23, this time we don't have a term in between our x squared and our constant with an x attached. And further to that, the number we have at the end, the constant we have, is also a perfect square, which means we could rewrite our expression on the left as x squared minus 5 squared is equal to 0. And if we factorize out this on the left, we get x minus 5 multiplied by x plus 5, and that's equal to 0 like that. And now we have one term in brackets and a second term in brackets we multiply together to equal 0, which means they're both equal to 0. So we say x minus 5 is equal to 0, and we say x plus 5 is equal to 0. So x is equal to 5 or x is equal to minus 5. And those are our two solutions to 23. Now factorizing 29 is going to be a little bit more awkward, but not impossible. The easiest way to factorize a quadratic trinomial where we have a number in front of our x squared is we turn it into a factorizing by grouping. And the way we do that is we first multiply the number in front of x squared by the constant at the end. So we're going to multiply 3 by minus 5, and we're going to get minus 15. And now what we need from this minus 15 is we need factors of minus 15 that will sum to give us plus 2, which is our number in the middle of our expression here. So our factors of minus 15 are going to be 1 times 15, or minus 1 times 15, or 1 times minus 15, both of which don't fit our criteria, or we'll have minus 3 times 5, or 3 times minus 5. And as you can see, minus 3 times 5 multiplies to minus 15, and if we added minus 3 and 5, we'll get 2. So this is the pair that we're looking for just here. And now we're going to take those numbers and we're going to split up our 2x using them. So we're going to have 3x squared minus 3x plus 5x minus 5 is equal to 0. And now we can group these into pairs on the left and factorize them out. So that's the first set of pairs, our second set there. From our first set to the left here, our highest common factor between 3x squared and 3x is 3x. And then we're going to put inside brackets x minus 1, like that. And from our second pair, our highest common factor is going to be 5. And inside our brackets we're going to have x minus 1. This is all still equal to 0. Now from here you can see that our common factor between the two terms we have is x minus 1. So we're going to put that in a bracket all by itself over here. And inside our second bracket we're going to put what was outside our brackets on the line above. And that is 3x plus 5. And that is still equal to 0. So now what we have is we have a term in brackets. Term in brackets we multiply together equal to 0, which means we set them both equal to 0. So we say x minus 1 is equal to 0, and we say 3x plus 5 is equal to 0, And if we solve both of these out, we get x equals 1, and then for the one on the right, it goes down to 3x equals minus 5, which means x is equal to minus 5 thirds. And those are our two solutions for question 29. And that is that.